All right, hello everyone. Today we're going to be still solving quadratic equations, but this time we're going to be using it with special cases. So at this point we can use what we call the square root method. Now this does only work for special cases. So if you're looking at the examples below, the first two are different. They are pretty normal. We are going to look if there's a greatest common factor that we can factor out, and if there is, we're going to start with that. Then we're going to factor using any method. So if there is our a term or our number in front of x squared is going to be just 1, then we factor like normal. Find factors of c that add up to b. If there is a value in front of our x squared term or a value, then we can use the bottoms up, or we can use the factor by grouping. And then the last thing is, once we get those factors completed, we are going to set them equal to 0 and solve. So if we're looking at this first one here, we have x squared plus 2x minus 35. So this is the same as saying ax squared plus bx plus c. So we have to figure out factors of c that add up to b. And since our a value is 1, we do not need to factor by grouping or bottoms up. So remember that our c value in this case is negative 35. So in order to multiply to get us negative 35, one has to be positive and one has to be negative. So factors of negative 35 that add up to 2 are going to be negative 5 and positive 7. So that gives us positive 2. And then if we multiply them, negative 5 times 7, that gives us negative 35. All right, so our factors for this are going to be x minus 5 and x plus 7. Both of these are equal to 0. Now remember, when we do solve, we have to do the opposite operation, so adding 5 to both sides, and we end up getting x equals 5. And then over here, we're going to subtract 7 from both sides, and we get x equals negative 7. So these are our two solutions for this. We can always plug them back into our original and see if they end up working. So if we were to plug in 5 for our x squared, that would give us 25. If we were to plug in 5 for the 2x, we would get 10. And 25 plus 10 is 35. Minus 35 gives us 0. If we were to plug in negative 7 for our x squared, negative 7 squared is going to give us positive 49. 2 times negative 7 is negative 14. So 49 plus negative 14 gives us 35. Minus 35 gives us 0. So both of them do work in this case. All right. Our next one here, we have v squared minus 5v. So at this point, we notice that we actually do not even have a c term. Our c is essentially gone. It doesn't exist. So since we have that, we are going to look at that greatest common factor. And if we look at both of these terms, both of them have a v in common. So we are going to divide out by our greatest common factor and leave that on the outside of our parentheses. And so when we do that, we end up getting v times the quantity of v minus 5, because v squared divided by v is v, and negative 5v divided by v is negative 5. So now this is actually completely factored, so all we need to do is set them equal to 0. So if we look at this, v equals 0. That is one of our answers. It does equal 0. If we were to plug it in, 0 squared minus 5 times 0 is 0. So 0 minus 0 is 0. It works. Over here, if we add our 5 to both sides, we end up getting v is equal to positive 5. And this also works, again, going back to our original problem, v squared, 5 squared is 25, minus 5 times 5, which is 25. 25 minus 25 is 0, so they both work. Now, our next problem, we're going to use our square root method. So here, our square root method, we see that the first term, ax squared, we do not have a bx term at all, so we do not have just x by itself. What we do have is a c. So we need to figure out what two factors, when multiplied, give us negative 64, but add together to give us 0. And that should be negative 8 and positive 8. The other thing that we can do is, seeing that we only have two terms, both of them do not have a variable, these are both what we call perfect squares. So we're going to take the square root of them, remembering that this is the difference of perfect squares. So that means we have to have one being subtraction and one being addition. And that is so that our middle term, or our bx term, ends up being 0. Negative 8 plus positive 8 is 0. So that cancels out our middle term, but negative 8 times positive 8 is 64. And it is a negative 64 because we have a negative 8 times a positive 8. If we set both of these equal to 0, we will end up getting x equals 8 and x equals negative 8. And both of those are true solutions. And we can, again, I told you earlier, you can always test that by plugging it back into the original problem. X squared, so 8 squared is 64 minus 64, that gives us 0. Negative 8 squared is also 64 minus 64 is 0. So it does work. All right, so here, if we look at this one, we can tell that there is a 2x squared, there is no bx term, and the c value. Well, our problem is that 2x squared and 72 are not perfect squares. So what we can do is we can divide out our greatest common factor, which in this case, again, is 2. So we were able to factor that out, and we got x squared minus 36 equals 0. Again, if you didn't know 72 divided by 2, you do it on your calculator. So now I'm going to focus on x squared minus 36 equals 0. So this goes back to what I was saying when you can see that these are both perfect squares, but they are different of perfect squares. So our factors will actually be 2 times x minus 6 and x plus 6. So when we end up setting this up to solve, we actually don't need to do anything with this 2. We don't need to distribute it back in or anything because 2 equals 0. And does 2 equal 0? Your answer should be no, it does not. So that is not a true solution. But now we have our x minus 6 equals 0. We'll add 6 to both sides, and we end up getting x equals positive 6. Over here, when we do x plus 6 equals 0, we end up getting x equals negative 6. And so these are our 2 true solutions. Again, we can plug those back into our original problem. X squared, let's say, is 6. 6 squared is 36, times 2 is 72. 72 minus 72, 0. If we plug in negative 6 for our x value, negative 6 squared is 36, times 2, 72. 72 minus 72 is 0. All right, and our last problem here, we have 25x squared plus 9. Both of these are perfect squares. However, we also know that both of these do not divide by anything. So it's not like we can have 25 and 9 both go into 5. Well, they don't. So I just noticed one thing as an error. This should be a negative 9, and I'm sorry about that. So what we're going to do here is, again, we know that these are perfect squares, and it is the difference of perfect squares. You can solve this 2 different ways. You can solve it like we've been doing. Take the square root of both sides, and you get 5x minus 3 and 5x plus 3. Or you can add 9 to the other side over here, which will give us 25x squared equals 9. Then we're going to take the square root of both sides, and when we do that, we're not going to do the square root yet. We're going to divide by 25 first, and then we get x squared equals 9 over 25, and then we are going to take the square root of both sides. Remember that the square root of something is always positive and negative. So this is going to be the square root of 9 is 3, and the square root of 25 is 5. And it is also negative 3/5. And again, that is because negative 3/5 times negative 3/5 does give us positive 9/25, just like 3/5 times 3/5. Okay, now this is one way that you can do to solve. So on numbers 3, 4, and 5, you could have done this method for all 3 of them. Or you can do the method like we did with number 3, or the method like we did for number 4. Again, it kind of depends on what you're given in order to do those. So if you guys have any more questions, remember to contact me via email.